So I announced it to be under an hour session. Maybe we can do it under 30 minutes. The wind is blowing. The wind is blowing, yeah. All right, so I'd like to ask first how many of you actually know about Kotlin? Something? Okay. I will assume that you know something, but not much, right? Maybe you just know everything and there is no point for you to be here. But anyways, my name is Anton. I work for JetBrains. I'm not working on Kotlin programming language. I work on TeamCity. But we are using Kotlin a lot. And we expose Kotlin also as a configuration option for TeamCity. And that's probably one of the reasons why I'm talking about DSLs here. So if you talk about DSLs, you probably know something about domain-specific languages or have heard this abbreviation DSL, right? Meaning that it's domain-specific and it's tailored for a specific task, right? So it narrows down the application area, but it kind of allows you to express something in terms of that domain. So if we try to think what are the options for DSLs, there are, like, in theory, there are external DSLs and internal DSLs. And you probably know what's the difference. Do you? OK. So external DSLs, for them, you normally develop a grammar. You develop a parser, lexer, parser, generator. You basically create your own fully fledged language, right? And compiler for that as well. Internal DSLs take advantage of a host language. And basically, you don't have to create a grammar. You only develop a vocabulary. So for instance, to develop an external DSL, at JetBrains, we have a product that is called MPS, Metaprogramming System. And there are some similar systems as well. Like in Eclipse, they have Xtext, and there are some other workbenches, basically, where you describe the grammar. It generates a parser for you, analyzer. It also generates ID support out of the box. So it's kind of a fully fledged product that you can use to develop a language. For internal DSLs, normally you use like a general purpose language, which is expressive enough. Like in our case, it will be Kotlin, but it could be Scala, it could be Groovy, and so on. They basically give you the same abilities in many cases, but slightly different in some specific areas. So we are going to stay on the dark side today because there are cookies. And first of all, I will actually show you a few examples of DSLs, internal DSLs in Kotlin. And I want you to follow carefully, and maybe you can spot something. Right. So the first example is about generating HTML documents. Right. So if you don't even know anything about Kotlin, you'll see that. Well, you will understand what it is, right? It generates HTML document. The other one is Anko. It's actually also developed by JetBrains. So we have a few libraries developed at JetBrains which take advantage of Kotlin language as a DSL host. So for Anko, this is the Android library to generate layouts. And again, if you don't know any Kotlin, basically it's very easy to see what it does here, right? So there are two text fields and a button. Obvious. Another one. This one is not developed by JetBrains itself, but actually by one of the former JetBrains employees. So if you are using Kubernetes, you have to often write YAML as a configuration file, right? Or many lines of YAML configurations, which is not a language, it's a text, right? It's a format. And I guess this guy was pissed off of that, and he wanted some type safety. So he developed his own DSL for that. Another one is TeamCity. I will probably have time to actually show it in real application. But the point is that with Kotlin, you can describe builds inside TeamCity. Pretty much the same way as if you are familiar with Jenkins, do you? OK, there you describe the builds in Groovy language. There is pretty much similar thing for TeamCity, but in Kotlin. Another one, there you will see a little mix of two DSLs, actually. So Ktor is a small framework for reactive web applications, and it kind of provides you the DSL to set up the routing in your web application, handle response, handle request, like serve the response. And there below you will see that something similar from the first example, right? So we are intermixing two DSLs in one file already. But the point is here that it's an internal DSL. It's just an idiomatic way to use Kotlin. So we can mix them in one file, and we are not creating any new grammar there. It's the same Kotlin programming language, so we can mix as many DSLs as we want. Okay. So did you see any similarities between those different examples? Did you? What is similar there?
Lots of curly braces.
Nice. That's kind of obvious, right? What else? It's close. It's like very, very close, what I wanted to say.
There is a word and something in curly braces.
Okay. And then there is another word, and there are some more curly braces. Basically, what I wanted to say is there is nesting. Then you will see a structure there, right? So when you have nesting, then you have structure. Okay. So how the structure looks like. So we open a block after some call. There will be another one. There will be some assignment maybe. We initialize some attributes. We can initialize the attributes with the other blocks as well. And also we have some syntactic sugar to make it, to add more features to it. And since it's Kotlin, we can actually not just provide the values, we can instantiate objects, right? So it's a valid Kotlin program. We can extract the whole block into a variable as well, right? As we did inside, it could be outside as well. And of course, it's all syntax highlighted and IDE assisted. And it feels like magic when you actually see it. So I would like to show you an example, and we will see how one can create this kind of nesting with existing Java classes, for instance. So I have an IDE here. Is the font big enough?
Yeah.
Good. So I have a Java application here, a very big one, pretty advanced. Everybody can read and understand what it is, right? A few classes, normal Java classes that have some fields, getters, setters, everything as we like normally. And I will take this code and start transforming it in Kotlin to get this kind of nesting structure to get the same result. So one limitation that I would assume here is that all the Java classes are somewhere in the library, not in my project, but I have them as a dependency, right? So I cannot change them. So I will just copy this code into a Kotlin file. And the very first thing that IDE will actually tell me that I can transform it for you, automatically. Okay, let's do that. So transform something for me, and well, if you are familiar with Kotlin already, there is not much you can see, not much new you can see here. But those who haven't seen Kotlin yet, but are familiar with Java, you will see three small differences at first. First of all, there is no type on the left. Second one, there is no new keyword. And the third one, there is no semicolon at the end. When I first learned about Kotlin, I thought those are like the least important things for me. When I started to program Kotlin, I also didn't notice those. But when I had to go back to Java, that was very annoying. I was always forgetting to type the semicolon there. Of course, we can actually write the type on the left, but on the right side from the variable, where is that? Specify. Yeah, so we can do something like this. But the IDE will tell us that this is not needed and remove that. Also, field assignment is not actually the field assignment. It's actually a setter call, right? So those are real properties that we have there. But we haven't changed much. The structure of the program is still the same. Let's actually see if it runs. I think the compilation would take ages, but anyways, we have a lot of time. Okay, so you can see it prints out the line and some reference to the object, right? And doesn't have any values because client Java class doesn't have a toString method, which is annoying, right? And I would like to print something meaningful there. Why not to change something? And I can't change anything actually because the client is in the library, right? I have it as a dependency. I cannot change the source code for that. That's my limitation here. And normally, a good Java developer would do the following. He would implement a class, client, util, and start writing static methods there, right? Basically, something like this, right? So if you didn't really understand what I said, client, it's Java, right? I'm writing Java. Util, and start typing something like string to string method that takes a client, and I would, compose a string out of the values, right? Not very idiomatic in Kotlin language. Instead, in Kotlin, we have extension methods, and we could do that with extension methods. So client to console string, for instance, let it return string. Of course, it should be fun. Otherwise, it's not fun. Damn it. Okay. And then it should return some meaningful string there, right? So we have access, since it's an extension function, everything that is inside the body it actually refers to the inners of the client itself. So we have access to everything what is inside client. So for instance, to Twitter, right? So if we get Twitter handle, and let's say it should be company name. Company name, right? We can actually write this kind of code as well as a template. Convert to template instead. I think it's a matter of taste, but maybe someone likes it better. So instead of doing this, we could actually call this toConsole string method in here, and let's see if it actually prints now something meaningful. Yes, it does. Good. So that's, did you know about extension methods in Kotlin? How many of you? Okay, so that's basically the same code as I was trying to write in Java before, right? What it generates in bytecode, basically, it generates that utility class and passes in the client as an object to that method and basically does the same stuff. It's just more idiomatic for Kotlin. But this extension method here is basically a building block for us when we want to create the nesting structures. Yep, the question there.
Can extension method overload existing method?
It's a good question. I always get this question. I always forget the answer, so I have to check. Maybe we can check later.
I think no.
Otherwise, it breaks my flow here. You can try it. I mean, I don't remember. Is it important right now?
Yes, because in the example, you can overload the string method of the general object. Then you don't need to call this toConsole string. You just extend to string.
It's a static method, right? ToString is a virtual one. You cannot override it with static one, so it will not collide there.
Okay.
Okay, so this one was pretty obvious here. Actually, we can type it slightly shorter without return statement, and since it's just one-liner, we can use the equals sign and just return the string here. But it looks a little bit ugly actually because I have to type those braces. You see, like if we are just writing a normal program, it doesn't make any difference. Like it's okay for someone maybe it does, but normally it's not a big deal. But if you are writing a DSL, every character you win, you make it your DSL actually more usable and cleaner to read. So if we can get rid of the braces, wherever we can, we should get rid of them. So actually what we can do here is do something like this. Instead of adding an extension method, we can have an extension property the same way. So val client, damn it. You know that the new Mac keyboard actually sucks.
Does IntelliJ help you just to generate?
I think we can try, but I think it will not. Member property.
Extension property there was.
Okay. You see it was trying to generate something. Extension property, good. Target. Okay, so it did. So it could be string. And then we basically implement the same thing, right? Good. Return, like this. All right. But that's just a small example here. It's we didn't really proceed with all those transformations. We didn't really proceed to our goal. It's just like a small building block for you to understand what will be next, right? Okay, so you remember that every example that we saw in the slides was starting with some method, like create HTML, create something. And here we will have like our entry point will be create client method, basically, where we will actually add all this nesting inside. So what I will do here is instead of building the client, my client object through the builder, I will actually start from the top and call a create client method. And there inside, I will start creating my structure, right? And we are going to do that step by step. So first of all, what we need here is this method, obviously, that should return client. And it should take in a block of code, right? Because this is what will actually pass into the method to create the object. So if we start thinking in a Java way, are you Java developers here, by the way? Many of you? Okay. Those who are not, who are you? I mean, I need some references. Kotlin developers, Android developers, then maybe. Okay. Anyways, like what we want to do here is to pass in a block, right, into a method. Like in many other languages, this kind of concept exists. So in Java, why I asked about Java is because I'm going to use Java abstractions first and then replace them with Kotlin abstractions. So in Java, there is an interface called consumer. In Java 8. You know what it is? So basically used almost everywhere in the new APIs, and it represents an operation that accepts a single result, a single input, and returns nothing. So basically a block of code that our method will execute and return nothing. And it should be parameterized, and that is the block of code that will actually instantiate our client object. So we need a client builder here. Client builder. So next, it's just simple. We need an instance of a client builder, pass into that consumer, and we get our result. So val builder equals client builder. Next, we need to pass it to the consumer builder and return nothing, but actually the builder will be initialized, so we can get a client instance out of there, right? Okay, that's our method that actually basically does almost nothing. It executes the block of code and gets the result out of the initialized object, which is the client builder. On the call side, what we should do now is to basically create that block, right? Create that piece of code. We actually have that already. We need to pass in this piece of code somehow into that method. So we need an anonymous, basically anonymous class to do that. In Java, you do that all the time. In Kotlin, it's quite unusual, but you can do that as well.
You can just pass lambda there.
We get there, right? Currently, we cannot do that because we consume an instance of the consumer. So that's the point. So you will see how it transforms. Consumer, client, it should be client builder, right? And we then need to implement a method, and we have this implementation right here. So we actually don't need this guy, and we can just copy this piece of code right there. And obviously, the builder does not compile because it's named somewhat weirdly, but now it compiles. So we have a first step towards the nesting right now. ID actually tells me already that, hey, you're doing something weird in here, and you can convert to lambda. So let's try that. And we don't need to parameterize it anyway, like this. But still, we have this consumer interface because we started with Java abstractions. Now we can actually get rid of it because Kotlin has this first class lambdas in the language. And to do that, we can replace the parameter type from the interface from Java library with the lambda itself. It should be the same semantics so that it takes a parameter but returns nothing. And since it's a lambda, it's not an interface anymore, we can just invoke it. And we can remove this declaration from here. So we have a real lambda now from Kotlin. So we got rid of Java abstraction in the middle. Now ID actually tells me, hey, you can move out the lambda out of the parentheses because it's the last parameter in your call. And in Kotlin, if you have lambda as a last parameter, you can move it out of the braces. So Alt-Enter, and basically what happened, it removed the braces, those normal ones, because we have just one parameter here. Now, in Kotlin, if you have a lambda with one parameter, there is an implicitly named argument, right? So it should be, we can actually give any name there, but implicitly it's called it, as in Groovy, if you're familiar with Groovy. And if we define it like this, we can actually amend it for good. Just remove it there. And as you can see, the ID actually hints us that it is an instance of a client builder. So whenever we call it.something, we call a method or a property on a client builder instance within this block, right? But still, it's a little bit ugly to call it and to refer to it directly. It would be nice to actually get rid of this it everywhere. Now, if I was about to remove this from this call, it means that I need a first, basically, direct access to that first name without it, meaning that inside the block, I shouldn't have it as a client builder, but I should have this as a client builder. And that's also possible if you now think of extension method, which we saw in the beginning, right? And now you think of a lambda as a method. Why couldn't lambda be an extension to a class as well? So instead of having a lambda, we will have an extension lambda on a client builder, like this. So the only thing we changed now, basically we told that the block of code that we are going to execute should be executed within the context of the client builder class. And you see what happened? It is red, right? So it doesn't exist, and this is client builder. So we have a direct access to the first name. Good. So we can get rid of it for good. And we already have created a clean nesting to the first level of the object.
A different way inside?
No, it's the same way. There is no difference from this point of view. So we have our first nesting, and obviously we can do the same to these guys as well, to Twitter handle and to company name, and we can do that easily. Fun. Oh, actually, first. So what we want to do here is Twitter block and initialize a handle like this, right? And we don't want to write it like this. But now we are in the context of client builder, and client builder doesn't have a property or a method called Twitter. What should we do?
We should assign.
No.
Twitter equals.
We would create another extension. We would actually create another extension. Fun client builder Twitter.
What means underlined property?
Where?
It's
Oh,
mutable.
it's mutable. So
Mutable.
if it's assigned, then it's.
The same with Java.
What do you mean the same with Java?
In Java, the same. It underlines mutable.
Since the previous release, this feature was implemented in DEVCLUB.EE, yes. If the variable is reassigned, then it underlines. But here, it's not just assignment, it's a setter call, right? Right. But yeah, basically it reassigns something there. That's why it's underlined. Okay, so Twitter, and we should initialize our Twitter field somehow inside client builder. And we should do the same trick to pass in lambda with extension. Extension, how we call it, basically it's lambda with the receiver is the official name. And this part here, whatever you write inside this block should be happening where?
On Twitter builder.
In Twitter builder, right? So if we do Twitter builder, ooh, almost like Scala. Now we can see this is Twitter builder, and handle actually already compiles, right? It just does nothing right now. But inside our method, we can now assign to the field Twitter builder, and we need to execute the block now. And in this situation, we need to execute the block within the context of that Twitter builder instance. And for that, we can use apply method and pass in the block. And now, since we initialize the Twitter builder, we execute the block, now it's initialized. We can just call build on that and get an instance of Twitter out of the Twitter builder. So, and it compiles, right? So if we just test, who writes unit tests, we can just always execute our code anyway. So it works. And we can do the same for the rest. What we actually want to do is like create a company block move those lines in here, remove this line, and do something like this. So it will be a similar method, but instead of Twitter, we are going to use company name, and it will be company builder, and it should be company builder as well, and of course it should be company. Good. That's simple, right? So what we started with was what was it? Example. This was a pretty simple code, but if you think about it a little bit, you actually have to go through each line and to understand what it's doing. So there's nothing wrong like by default with this code, I would say. But on the right, now we have a structure with all this nesting, and it's very easy to actually just with a blink of an eye understand what is it doing and what is it for. Okay, what else we have here? So we have a structure, and but we create it for one-time use only. What's the benefit? We just introduced the complexity in our code, and there is no big benefit. Our colleagues hate us, and what do we do with it? So there is a point for this if you can reuse this DSL, actually. So imagine I'm extracting it to a library. So I will just delete this code from here. And imagine that I have a library, actually, which is implemented right here. All the same methods, like this extension, builders, and so on, right? OK. Now, since we are extracting it into a library, our purpose is to give this library to the users, maybe to our colleagues, maybe to the consumer of a product. Like in our case, it's TeamCity, we give them the DSL to actually configure the build job, right? So what if the users start using your APIs or your vocabulary unintentionally in the wrong way? For instance, they could let me actually they could start intermixing these calls like this. For instance, they could move this block inside the other block, right? In this case, since I have all this code written already, the compiler tells me that, hey, you are doing it wrong. But how it's done? So you can see that the hint has changed slightly, right? So it's not a company builder or Twitter builder. It's the Twitter builder DSL and company builder DSL and so on. What happened here is that we can annotate the classes that participate in the DSL, in the model of the DSL. We can annotate them with a special annotation, which is called Dsl Marker. And that's a meta annotation. We cannot use that annotation directly. We have to create our own, like client DSL. And then we can use this annotation to annotate the classes that participate in the DSL. Now remember that limitation that I had. I couldn't change the Java classes, but I actually can derive from them and annotate them directly. So instead of annotating company builder, I'm deriving from the company builder and annotating that. So now I have to use that new class in my DSL methods, client builder DSL and company builder DSL and so on. So basically replace the old classes, the Java classes, with the new DSL classes. And now the compiler will get a hint how to check the receiver of the new method that I have created in my DSL in this place, right? So if Twitter builder DSL doesn't have a company method, the compilation will fail, right? So if I remove those annotations, basically I remove the DSL marker, everything compiles, right? So that initial example that we had, it would compile. And in this simple case, it even would produce a correct result, but you never know, like, maybe you didn't intend the user to actually use your APIs like this.
But why it doesn't compile? Where does it get its component method?
Because it's a global scope. Oh, global scope, I mean like this scope, right? This company method exists in client builder DSL, in here, in this. So it gets it from the outside, and it's actually a correct usage, because you cannot restrict restrict the scope to the narrowest one, because it becomes impractical. You need to be able to call to the classes, to the functions. Maybe you have some utility classes in some libraries and so on. Otherwise, it becomes useless. But you need something to control the scope. So in this case, this annotation actually helps us to fix it. Another option, like where the user may create an error when he is using your DSL, is to forget to initialize something. Suppose you expose two fields, right, inside that block, or two attributes, and you as a DSL author, you require the user to fill in the name and the city, but he only assigns to the name, and there is no compilation error. So this is not currently implemented, but this is something that I know the team is working on, is to actually provide you the tool or an option to create a contract for those kind of blocks to require to initialize the fields. And if something is not initialized, it would be a compiler error as well. So that actually, for you as a creator of the DSL, it actually means a little bit more work. But then for the consumers of the DSL that you create, it makes it much more pleasant to use. So the other things that you actually get with that annotation that we have just seen a few minutes ago is the fact that you can actually annotate the methods as well. So I annotated the classes, but I also annotated the methods. And it actually helps the tooling, so that when I want to complete something, you get the DSL methods on the top of the completion list. So imagine if your DSL is slightly more complex than this one, not just 3 classes, but 300 classes, and you want a good completion for that as well from your IDE. First of all, you need those. If you're inside the DSL block, so-called DSL block, you want those. You want to get the options as faster as possible without scrolling down. So those get placed on the top, and they also have a different color, so you could distinguish them. At first sight, if it's just a program, if it does nothing, you don't see a big benefit. But if it's a configuration file, then it's a great benefit, because it allows you to explore the format of the configuration, what values you should be using, what methods you should be calling inside, those nesting blocks and so on. All right. So what else could I talk about? I actually have showed you everything. Have any questions?
Perhaps you made it so clear that no questions.
Wait, it's not everything actually. So whatever I showed you right now is actually a one documentation page. Type-safe builders is the concept. You go read about that. There is an example how the HTML library works, what is the lambda with the receiver, what is the extension method, and so on. Another cool feature is infix notation for the methods. So suppose we have a client, but it's not only, it doesn't only have a first name, last name, Twitter, and company. It also have a birthday, right? As a person, where is that? Okay, where is client? Client. So he has a birth date of birth. Okay, local date, and we want to assign that as well. Okay, date of birth, and then local date of, what could be the date? 2001, December 14, whatever it is. Not very DSL-ish, right? It's basically the API call from Java, and it doesn't look nice. It would be much nicer to actually be able to write something like this. 2001, no, December, 14th of December, let's say 2001. Nice, isn't it? But what it actually is a method call on the number 14 with the braces and an argument of 2001. So the fact that I could do that is basically the infix notation that I was using. And let me show you how it works. So here's the method. It is an extension method. So it has one receiver. It's an extension method on an integer, and it takes one parameter as an argument. For this kind of functions, we can declare that those are the infix functions and amend the dot and the braces and get a slightly nicer notation of writing this kind of things. Nice, isn't it? Okay. One little thing that I have experienced with using the DSLs myself already is this fact that you can forget to assign something. And since there is no way to control and check and give the compilation error if you forget to assign something, you only can rely on your design skills. Basically meaning that you should be able to write this kind of method or declaration of the method that would force the user or hint the user somehow, hey, you should assign this value. And since it's just a normal function, we can actually, suppose we need an ID for a client, always. It's an obligatory value. And we need to somehow hint about it to our users, our DSL users. So the original syntax, almost the original syntax of this method call is like this, right? So it compiles, everything is good, but we can just amend those braces. But we can also pass in any list of parameters right here, right? So what if we hint to the user that, hey, we actually need an ID, something like this. And then the parameter would be this one. Okay, it should be a little bit different order. So on the first place, there will be the ID. It can be null, for instance, but it already gives a hint that, hey, you should fill in the ID. It doesn't give the compilation error, but it's already a usability increase, I would say. And since there is like a nice syntax sugar when you can have name parameters in Kotlin, then it's nice to actually define the name right here. Because if you open it, say in the normal editor, like VI, for instance, the ID actually helps you with that. It tells you that there is a hint, it should be the ID, but text editor would not. So I would advise to actually use this kind of syntax for this kind of situations. And then it makes it much easier to use.
Also better refactoring because you don't need to follow the order of parameters.
Yes, besides the lambda.
Oh, if you have multiple parameters.
Yeah, so lambda should be the last one.
Yeah.
So the real example for the DSL would be something like this. This is the DSL from TeamCity. And we can actually check the definition. So we can see the nesting here again, right? Project, build type, ID. There's more nesting and more nesting again. So and we can also see that there is like a this and some kind of a type after the declaration. So if we go inside the block, or we go and check the definition of this block, you'll always find lambda with the receiver, which basically hints you that, hey, this is the most important language construct that you should have learned today. And if you check another one, there will be also lambda with the receiver, right? So it will be everywhere. So today, if you did not understand anything what I was saying and everything was total bullshit, then remember about this thing. In Kotlin, there is lambda with the receiver, language construct, basically language sugar, syntax sugar. Looks like this, and it's very useful for creating DSLs. With that, I actually would like to finish, and if you would like to learn more of Kotlin, there are some cool books, and actually my colleagues are currently working on the course on the Coursera. It's already ongoing, so you can file in the assignments and get them checked. And if you have any questions, just ask me. Thank you very much for listening.
Thank you, Anton, so much. As always, it was great to have you. One small addition from my side. It has a lot in common with Ruby community. People are really obsessed with
The DSLs.
DSLs and writing code in a nice way, convenient, and favor convenience over maintenance sometimes. And
I can only add that they don't have static types.
they don't, yes. But
My condolences.
I mean, you also like showed examples where you sacrifice features or safety of compilation right in order to gain convenience in
No, actually, I haven't sacrificed anything. It's the normal Kotlin code. I can debug it the same way.
Yes,
I get the type completion.
You can actually abuse it, but still don't get compilation errors in this sense.
Okay, you mean that I haven't assigned anything inside the block, of course, but then it would happen with the normal code as well. So it's not like there is no sacrification in any way.
Or perhaps. Anyways, thank you people for being with us tonight. It was great to have you, and then see you.
There's some
in
cake,
January.
maybe.
Yeah, there's still some cake left. Have some. Enjoy. I tried both. Delicious, both. And this is it for tonight. Probably there will be some. There's still something going on in Russian tier. Starting DevOps probably already ended. And Evgeny wanted to add something, no? No?
Come to next event.
Yes. Please join us on January as well. Happy holidays, Merry Christmas, and
Happy New Year.
Happy New Year.
Okay.
And thank you all the speakers, guys. You were awesome tonight.